Okay, so this is part 2, and this is the back side of your notes. So this is what you should see on the back of your notes. So for example A, the following histogram shows the ages of people watching comedy movies and animated movies. Describe, and compare the shapes of distributions. Okay, so based on what we know from the first part of our notes, we're looking at this graph, and just look at this graph and look at what you see, look at what you notice. What do you wonder, what do you notice? So all the data already we can see is mostly on the left, and then this tail where all the data starts to shrink, where it gets smaller, the tail right here is going towards the right. So most of the data are on the left, and the tail extends to the right. So the distribution is skewed to the, what do you think it is? To the right. Because the tail is extending to the right side of the graph. So wherever the tail is extending to, whatever side the tail is extending to, that's where the distribution is skewed. The distribution is skewed to the right because the tail is extending to the right side of the graph. All right, so for this next one, so we're going to be comparing these two histograms. So this is the animated movie attendance, and this is the comedy attendance. Now, what do you notice is different about this histogram? Okay, so this one, we notice all the data is towards the left, and the tail is extending to the right. But for the comedy attendance, it's opposite. All the data falls to the right side of the graph, or the histogram, and the tail is extending to the left. So most of the data are on the right, and the tail extends to the left. Okay, so the distribution is skewed to the left. Okay, so we're looking at both of these. If we look at both of these histograms, we can see that it's opposites of each other. This data there's more data on the left, and it is skewed to the right, and there's more data on the right, and it's skewed to the left because the tail is going to the left, and the tail here is going to the right. Okay, so now that we know where it's skewed to, we can check which movie has an older audience. Okay, so again, the garbage truck is outside. Lovely, lovely. Okay, so which movie has an older audience? So the intervals, and what I mean by intervals, okay, let's hold on a second so the trash guy can do his thing. Hope you guys are having a lovely Monday, and if you're not watching this on a Monday, then I hope you're having a lovely day either way. Just waiting for the garbage truck to be done because I really do not feel like talking over the garbage truck. Yeah, this is what I get for doing this early in the morning. Okay, I think the garbage truck is gone. Okay, so all right, what I was saying, the intervals of both histograms are the same. Intervals meaning these intervals, so 10 to 13, 14 to 17, 18 to 21, 22 to 25, and so on and so forth, the ages. Okay, same thing here. It's the exact same intervals, the exact same not frequencies is up here. The exact same intervals are the same, so we can compare them both exactly the same. So if you look at the data, most of the data for the animated movie are on the, again, whereas most of the data are on the left. Okay, so we can safely say that are on the left. And so most of the data for the animated movie are on the left, and while most of the data for the comedy movie are on the, where's most of the data for the comedy movie? The comedy attendance is mostly skewed, or not skewed, mostly on the right. It's skewed to the left here. Okay. So that means all of the ages are older on the right hand side of both histograms. The ages are older on the right, and it's younger on the left side for the intervals. So what does that tell you? If there's more data on the right side, and those are the older ages, that tells you that there are more older folks or older people attending the comedy movies than attending the animated movies, because all of the data on the animated movie attendance are on the left, meaning there are more younger people watching the animated movies. So this means that the people watching, can't see that, watching the comedy are older than the people watching the animated movie. That makes sense, because just generally speaking, if you go to the movies and you'll see younger kids watching animated movies, and yeah, you'll still see kids at comedies, but you'll see more younger kids attending animated movies, and older people or older, and I don't like saying older people because it doesn't have a great connotation, but older people are watching more of the comedy movies. Okay, so this is why we study statistics, so you can see where does the data fall, and it can give you information like that, where you can look at a graph or look at a histogram or look at dot plots and say, okay, well, if all the ages, it's younger ages on the left and then there's older ages on the right, where does the data fall? If there's more data on the left, then I know that that's younger folks who are watching animated movies. And there's less older people watching animated movies. And for comedies, if I look and I see here, there are less younger people watching comedy movies and a lot more older people, because most of the data are on the right, and that's where all the older intervals are. Okay, so this is part of the reason why we study statistics, so we can see the data and it can tell us a lot of information that we might not know just based on just collecting the information. We have to put it in a graph, we have to analyze it. Okay, and that's what statistics is all about. Okay, so we're going to do one more example, and this should be your third page of your notes. Okay, example B, describe the shape of the distribution of the dot plot. Okay, so if you look at this dot plot, we can see, again, it's kind of making a hill, and then we can kind of go like this, and we see that the tail, or the smaller amount, or less data, is starting to fall towards the right, okay? And most of the data are on the, I hope you know, the left. Okay, so tell me, go ahead and fill this out on your own first. Pause it, fill this out on your own, and then restart, and then check your answer when you play the video afterwards. Okay, so pause it, try doing this on your own, then watch the rest of the video to check your answer. Okay, so I hope you paused it already. So most of the data are on the, hopefully you wrote down, are on the left, because see, most of the data falls on the left side of the dot plot, because you see for one, it said, and this is daily snowfall amounts, okay, and this is the inches of snowfall, and most of it falls under 1 and 2, okay, and then the tail extends to the right. This is where the data starts to fall. So the distribution is skewed to the, where's the tail going? To the right. Okay, so fairly easy. We're just looking at the shapes of distributions of graphs, and this is the last part of our statistics unit. So now what I want you to do is to do the try this. Describe the shape of each distribution. You're going to look at this histogram, and you're going to look at this dot plot, and I want you to tell me on the side here, I want you to do exactly what we've been doing. Describe what is happening in the shape of each distribution, and tell me, is it skewed to the left? Is it skewed to the right? Is it symmetric? Tell me that on the right side of the paper. Once you are finished, again, do not wait for me to stamp your paper until you move on to the next assignment. Go ahead and put your paper to the top of the desk, and I will stamp it and immediately move on to the next assignment. Okay?